Hi everyone, nice to meet you. Thank you for the opportunity. Maybe some of you know me on my nickname from GitHub, which is ScriptHunter7, and I am a bit active in this topic. So I'd like to extend a warm welcome to all of you who have joined for today's presentation. Because we dive into this exciting topic, I apologize in advance for any language difficulties, because English is not my native language, but I tried my best to convey the information effectively. So, the topic is, first, just a presentation plan. In the very beginning, I will begin by exploring the historical context. Then after that, I will take a short look at different ecosystems. And after that, based on these ecosystems, I would like to show AdGuard ecosystems for the development tools. And after that, finally, I will peek into the future. So, the beginning of Adblock rule syntax. Initially, Adblock rule syntax was quite straightforward, because there was just host rules, nothing else. Then after that, first Adblock was introduced. You can see on the screenshot the post. Henrik simply posted to the forum, "Hi, I created an Adblocker." And you can see the first comment on this topic. Innovation usually starts with some skepticism. So that was a very basic syntax with simple cosmetic rules, network rules, with very simple modifiers. Later, as we've seen, the journey of the Adblock syntax syntax begin with simplicity. But evolving of the needs of the digital land space demanded innovation. Over time, new language elements were introduced, such as allow listing, which makes us able to whitelist some rules, or advanced modifiers like redirecting resources, or extended CSS. Sometimes regular CSS is not enough for us to block everything efficiently, so we need some JavaScript-based CSS extension. Also, scriptlet rules, sometimes a site using an inline scriptlet code or something else, and we need to inject some script logic into the context of the site to make Adblock work properly. And network level HTML filtering rules also introduced. This makes us possible to filter the content of the site before it is loaded into the browser. So the source code which is loaded into the browser is filtered by a network driver, and no need to any other blocking in this case. And finally, preprocessor directives, which is used to handle different platform or anything else. For example, Chrome or Firefox handle a bit different way the compatibility. And in this slide, I will explore how programming languages provide valuable insights. First of all, we have simple text editors, which provides syntax highlighting. This is a convenient way to summarize our code. Every popular language has a syntax highlighting. Second is static analysis. In this category, there are a lot of tools like linters. With the help of the linters, you can detect various issues in your code, like unused variables, or bad practices, or in the case of the JavaScript, var keywords, which is outdated and anything else. And with the help of the formatters, you can format your source code based on some formatting rules. This is especially useful for large projects, collaborative projects. And there are some ecosystems, some new modern ecosystems like Go or Rust, which provides this ecosystem, this toolset by default. So, for example, Go have a formatter, linter, and you can simply use it. And one more important thing is IDEs, integrated development environments like VS Code or WebStorm. IDEs provides compatibility with these tools what I mentioned before, the previous slide, or code snippets, or auto-completion, or debugging tools that allow developers to inspect the problems with the code, troubleshooting issues, and so on. So this is the base. And building on this analogy to popular programming languages, what I said before, it's true for almost every popular programming languages. So we observed this, and we got a clean pattern that guides the evolution of Adblock filter lists and developer tools. So divide this pattern into 4 parts: syntax highlighting, linter, formatter, and integration into editors. So this is the base idea. And first is syntax highlighting. It is based on a TM language, which means text-made grammar file. This is a simple file which defines patterns, and they are based on regular expressions. Basically, VS Code or GitHub uses using such files to make code highlighted, and supports our syntax highlighting supports every popular Adblock syntax. There are some different syntax. We have some common parts, but there are AdGuard exclusive rules, or uBlock exclusive rules, or anything else, or snippet injections for Adblock Plus, or anything else. Our VS Code syntax highlighter support is quite old. We provide it since 2017, and linguist support from the last year. It's a bit tricky to submit a syntax highlighting to GitHub, because we need to fulfill some popularity requirements. But since almost every filter list are maintained on GitHub, we successfully applied a pull request into the linguist library, which makes us possible to use syntax highlighting on GitHub. And linguist is basically just a Ruby module that are used to detect programming languages in repos by GitHub. And the second topic, maybe the most important topic in this presentation, is the AgLint, which is a linter for Adblock filter lists. It also supports every popular syntaxes, I mean Adblock Plus, or Adblock, AdGuard, and uBlock Origin. These concepts are inspired by ESLint, which is a popular linter for JavaScript. On the screenshot, you can see the logo and what the colors in the logo are representing. So basically, the 3 Adblockers logo and the VS Code logo, because we implemented it first in VS Code. This project actually was released half a year ago, but we constantly improvement it. And how it works. The base concept, which you can see on the screenshot, is very simple. Linter takes the raw filter list, parses it into an AST, abstract syntax tree, which is technically just an object in JavaScript, and then the linter core traverses this AST, and you can run any rule on it. Rules basically has events when the filter list linting started, when a rule linted, and when the whole linting of the filter list was ended. And after all is done, linter simply can report the detected problems with a reporter interface. This can be anything. Basically, currently, we just implemented a simple console reporter, but you can use WebSocket or anything else in the future. So the concept is pretty general. And at this point, I think it is important to mention the parser itself, which produced the AST. It is called AG3. Of course, it is also handles every popular syntax. Where it is possible, it determines the syntax and writes the syntax as a property into the rule node in the AST. You can see in the screenshot a sample of the AST. So this is just an object. It writes rule type. For example, here you can see a network rule node, because it is very simple, but also handles cosmetic rules or comments, even preprocessor directives, hint comments, or anything else. So technically, it handles everything. And I also created a demo page for AG3, which is available. You can find it on the second link, but unfortunately, I can show you in this presentation. And what can it do, the linter? The most important thing is it detects errors and warnings, like syntax errors. It is important to mention that syntax error is a fatal error, because if the linter, so linter parses a filter list rule by rule, but if the linter can't parse a rule, it can't produce an AST node from the rule. And in this case, it is impossible to run every linter rules on the rule. In this case, you only have a raw rule and an error message, and the core automatically handles this fatal error. So it is always reported. And the second point is just violating linter rules. In this case, the rule itself is syntactically valid, but there is some problem with it, like unknown modifier or inconsistency or anything else, duplicated modifiers. So we can filter all type of errors in the linter. And of course, linter offers some customizations, because there are some cases when you didn't want to fix the rule, or you cannot fix, or something wrong in the linter, or new linter rule required, or anything else. In this case, you can disable the linter for an Adblock rule or a block of rules. So AgLint disabled, then AgLint enabled, or AgLint disable next line. And you can also disable one single linter rule, and in this case, linter apply any other rules. And we have an experimental feature which is provides a way to fix problematic rules, but this is very basic at this point. But in the future, we plan to improve it. And some other use cases for the linter. Basically, the AgLint is just a TypeScript library and a CLI tool which wraps this TypeScript library. But what other use case it have? For example, you can integrate it into CIs like GitHub Actions. So what this means in the practice? Simply, if you make a commit in your repo and you push it, GitHub Actions runs the workflow, and you can filter out problematic rules automatically in your repo, or you can validate your pull requests in the repo. It is working, as you can see in the screenshot. We already using it in the AdGuard filters repo. I also using it in my own filter list. I maintain the Hungarian filter list, for example. And of course, we can integrate it into the editor. And at this point, I would like to introduce the integrated AgLint into VS Code. As you can see in the screenshot, the tool in action. It's very similar to the CLI tool, basically just using the UI features provided by VS Code. And this helps a lot of the productivity of the maintainers. Because if something is wrong, they can immediately see in their editor. Okay, as I mentioned before, linter is constantly improved. So by working together, we can make AgLint a fantastic tool for every filter developers. Your opinion and your contribution is very important to us, and we are excited to collaborate with you as we shape the future of the Adblock filter list development. You can help us with testing AgLint, reporting issues. Simply just try AgLint in your filter list, and if you find any problems or do you have any ideas, we are happy to discuss with you. Or if you are interested in getting more hands-on, you can even send us a pull request. Rule interface is very simple and well commented and well documented. So if you visit the AgLint repository, you can easily contribute to it. And what's the next? Of course, we also have a lot of ideas for AgLint. So we opened a GitHub issue. You can see its link in the slide. We already collected a lot of linter rule ideas here, like checking a domain is still alive, or checking modifiers more deeply, or DOS attack in regular expressions, which can break the parser. So we already have a lot of ideas in the linter. And of course, we need to implement them. And your input is also very important here. If you have any ideas for linter rules or features of the linter, you can share them with us on this GitHub issue. Your suggestions are incredibly valuable to us to plan the future. And let's take the whole ecosystem. In the future, we also have some exciting plans, like formatter or rule orderer. These tools help organize us filter list more efficiently. There are some big filter lists, like AdGuard filters repo, or uBlock filters repo, or or there are some other very large filter repo. And if someone wants to contribute to these repositories, there is a common problem. Our user creates the rule, but where to put the rule? Which file, which line, and so on. And formatter and orderer can help us to force a consistent schema to every filter list. Of course, you can also configure this like the linter for your exceptions or anything else. And of course, we also can integrate formatter and orderer into the linter, and if the user violates the formatting, VS Code immediately show the error to the user. So thank you for your attention. We now have a short time for questions. Please don't hesitate to ask if you have any questions. Thank you.
Thank you, David. Who wants to get things started? There we go. Watch out. You're in the line of fire there, Hugh. There we go.
Okay, thank you for the awesome presentation. I would like to know, how do you distinguish the syntax of eyeo, AdGuard, and the Adblock in out-of-fix function, especially?
It is a very good question. There are two ways to distinguish syntaxes. The much low level is the parser. Parser itself adds a syntax property to the AST node if it can determine the syntax. It is not also possible. In this case, not always possible, sorry. In this case, the parser simply put a syntax property with a value common. In this case, parser could not determine the syntax. But we also handle the syntax in the linter via the configuration interface. You can specify the config property in the AgLinterC file. And you can also control the syntax with linter control comments in the file. So it's absolutely customizable.
Oh, so it's configurable, yeah.
Syntax is it is very important because, for example, linter also includes a compatibility table for modifiers. And here you can easily run into a problem. Some modifiers supported by AdGuard, but not by ViewBlock, for example, or vice versa. And in this case, it is important to know the syntax and call it like context, because if you run some compatibility check, you can't mix them within one rule, one single rule, and you should know the syntax and the compatibility context of the given rule which you are testing.
Thank you. I am answered.
Right, maybe you have time for one more. Anybody? Oh, way over that way. Two, way over that way. Whoa. Wanted to make us work.
Hello? Oh.
Hope my microphone is good.
Yeah.
Okay.
Is AgLint extendable right now? Maybe is it planned to write some plugin system for it?
Absolutely. Absolutely. Yeah. Like in the rule interface, I try to design everything in the linter pluggable and general concept. So we are also planning to add some plugins in the same way, I think, in the ESLint. So you can create your own node module and your own rules, and you can simply include it via the configuration interface of the linter.
Okay, thanks.
We had, I think, one more up here in the front. Still curious? We'll go for that one. That was quick.
Thank you. It seems like the product itself is really complicated and huge. So I'm wondering, how long did it take the team to build this product, and how many team members were involved?
Sorry, I don't understand which is complicated. I understood everything else. Just single word, sorry.
I'm curious about how long. Like, is it 2 years? How long did you build this tool?
To build this tool,
Yes.
almost 1 year.
Almost.
Almost 1 year.
1 year. And did you build it on your own, or was there a team?
In team, of course.
And how many team members?
We are working on linter in the extension stem team in AdGuard.
Thank you.
Team effort. All right, well, let's get it up for David one more time. Thank you so much.